So here this is a circuit in which a 5 ohm coil is connected across a source of EMF, and this source of EMF is sending what current? 4 ampere current here. So what will be the potential difference across this coil, across this resistor? It will be equal to V equals to I into R. I is what? 4 ampere, R is 5, that is equals to 20 volt. Here let me write it here, it's clear. Here potential difference will be equal to V equals to I into R, that is equals to 4 into 5 equals to 20 volt. Now you can measure the same potential difference, you can measure the potential difference by using voltmeter. So see here you will connect the voltmeter in the parallel of this. As you know that what is voltmeter? Voltmeter is an instrument which is used for measuring the potential difference across any resistor, and it is always connected in the parallel of that resistor across which you have to measure the potential difference. We will connect in the parallel of that resistor. There are one more thing. Voltmeter, for an ideal voltmeter, resistance should be infinite, but it is not possible to make the resistance infinite, so we will make it very high. So voltmeter is a very high resistance instrument, and why it should be a very high resistance instrument, that I will explain here. It's clear. So here, in order to measure the potential difference across this, we will have connected a voltmeter here. Now as you know that voltmeter is the modified form of galvanometer, therefore certainly it will have some resistance, and when it will have some resistance, what will happen? Current on reaching here at this point, it will divide into two parts. Suppose 3 ampere current goes here and 1 ampere current goes here in this side. 3 ampere is flowing in this side, 1 ampere is flowing in this side. What will happen? The potential difference will be equal to 3 into 5 after connecting the voltmeter. After connecting the voltmeter, what is the potential difference? After connecting voltmeter, potential difference V will become equal to I into R, that is 3 into 5 equals to 15 volt. Potential difference will become equal to 15 volt. Now what was the purpose of connecting voltmeter? To measure the potential difference across this when it is connected across this source. That potential difference was 20 volt, but now it will measure only 15 volt. It is showing only 15 volt. As you know that in parallel potential difference remains same. So the potential difference which is occurring here will be equal to shown by this voltmeter. Now here occurring 15 volt, so it will show 15 volt, while the actual was 20 volt. And why it is so? Because of the division of current at this point. Because of the 1 ampere current going in this side. If this is 0, then what will happen? Whole current will pass through this. And when whole current will pass through this, it will show the same potential difference 20 volt, and it will measure the 20 volt. So anyhow you have to make current passing through voltmeter 0. That is not possible. That can be minimized greatly, but cannot be made 0. It can be minimized greatly, but cannot be made 0. Suppose if you make this current equals to 0.001 ampere, then what will happen? Approximately most of the current will pass through this. How much current will pass through here? Through the coil, through the resistor? 4.999 ampere. It's clear? And when this much current will pass through this coil of 5 ohm, how much will be the potential difference? V equals to I into R. 4.999 into 5 means approximately equal to 20 volt. It's clear? Means there will be no significant change in the potential difference if anyhow we make the current passing through voltmeter to insignificant value, And how can you make the current passing through voltmeter extremely small? By increasing its resistance to a very high value. When the resistance will be very high, what will happen? Current passing through voltmeter will be very, very small. And when current passing through voltmeter will be very, very small, approximately most of the current will pass through the resistor across which we have to measure the potential difference. And when the most of the current will pass through the resistor across which we have to measure the potential difference, what will happen? We will get the approximately same potential difference which was actually occurring before connecting to the voltmeter. Now, as you know that voltmeter is the modified form of galvanometer, and galvanometer is already a very high resistance instrument. It means we have to increase its resistance to much more higher value. In the ideal case, it should be infinite. But it is not possible to make it infinite, so what will you do? We will connect a very high resistance in series of galvanometer. It's clear? Means to convert galvanometer into voltmeter. Connect a very high resistance instrument. High resistance in its series. Connect a very high resistance in its series. When you will connect a very high resistance in its series, what will happen? Its resistance will increase to a very high value. It's clear? Means it will be something like this. This is the galvanometer. A very high resistance R has been connected here. This will be the voltmeter. Now, as we know that the current passing through galvanometer is shown by the symbol Ig. It is shown by the symbol Ig. Ig is the full scale deflection current through galvanometer. So, what is the total resistance of voltmeter? Total resistance of voltmeter, that is RV equals to G plus R. This will be the total resistance of voltmeter. R is what? High resistance connected in series of galvanometer. Ig is the full scale deflection current, that already you know. So now see here, what will be Vg here? Therefore, potential difference recorded by voltmeter means that potential difference for which it has been designed. Suppose it can read a maximum potential difference of 5 volt, means V will be equal to 5 volt. So V equals to here Ig into what is the resistance of voltmeter? RV, or you can write Ig into G plus R. Ig into G plus R. This is one relation. Now this is written in the other form also. That other form also you remember. Now see here, Ig equals to, V equals to Ig into G plus R. So what is G plus R? It will be equal to V upon Ig. So what is R? it will be equal to V upon Ig minus G. So this is this way you will convert galvanometer into voltmeter.